All right, so we're looking at page 445, 446, looking at number 22. And if you look at that particular problem, it's talking about a design, which is like a piece of paper that's 16 by 9, and that's a design for the mural. And then the actual wall is 24 by 14, and that's going to be feet. So 24 feet by 14 feet. And we want to figure out basically how big of a mural will fit on this wall using that design. So first thing I notice is that right off the bat, I have a what issue? What issue do I notice right off the bat? The units are not the same. Would you agree? And so we can't really deal with anything unless the units are the same. So why don't we go ahead and just convert everything to the smallest unit, which would be what in this case? Okay, so we'll convert the 14. So 14 by 12, or times 12 is 168. So I have 168 inches here. And then we have 24, and that looks like 288 inches. Okay, good enough. Now, what I'm trying to figure out is basically I have this piece of paper. How big can I blow it up so that it will fit onto the wall? Okay, how much of the wall will be covered, that kind of thing. So I'm really looking to figure out what the scale factor is, right? So I'm going to be figuring out, okay, 9 times what is 168? Well, I don't think it's exact. 16 times what is 288? I don't know if that's exact. So we'll try that. How can we figure out what the scale factor would be? What would I do to get that? Divide, sure. So if I take 288 and I divide by 16, oh, I do get 18. I get an actual exact answer. So hopefully that'll work with 9. So 168 divided by 9, not exactly. So some of the wall will still be showing, right? But if I use the scale factor of 18, we would have 16 times 18 is 288. So that's one of the dimensions. What's 9 times the same scale factor? And that would give me 162. So the dimensions that I'm looking for here is going to be 162 by 288. And then I think the answer in the back of the book converted that back to feet. That's fine. But that's as big as I could blow up to be on the wall. Now I agree that you would have 4 inches still showing on this wall. But that's as big as we could make it without distorting it. Okay? Better? What other question do we have? 32. All right, 32. Oh, this is the map one. I think you guys are overthinking the map question. It's really not that hard. If you look at question 32, you are given, it's a map of Texas, I think, okay, or part of Texas. And it's asking you from San Antonio to Houston, okay? I'm not going to pretend to draw the map, but here's San Antonio, and there's like a little road, and here's Houston, okay, on the actual picture in the book. That's fine. The important part about this problem is it gives you a scale. And it says the distance from here to here is 1 centimeter equals how many kilometers? 112 kilometers. So think about what you did in elementary school. What did we do? What would I do here to answer the question? Well, I would get my ruler, and I'd do what? I'd put it in, what units would I be looking for on my ruler? Centimeters. And I would measure from San Antonio to Houston in centimeters, right? That is true. So you're exactly right. It's not exactly a straight line. No roads are exactly perfectly straight. So it would be an approximation. Okay, it would be an estimate. I agree with you, Marvin. So we would actually measure it. So I don't know how many centimeters it was when I measured it, but you would set up a proportion. You would say 1 centimeter to 112 kilometers equals, we're trying to figure out how many kilometers it really is, right? And I would use my ruler to figure out on the map how many centimeters it was. And then I don't know how many it was. Anybody actually measure it? 2 or something like that, maybe? Let's see. It says 2.8. Okay, fine. So 2.8 centimeters. And then you would just cross multiply and solve. Okay? I think you were overthinking that one. That was not meant to be a difficult question. Okay. Any other questions from homework? Yes. 37. Okay. Let's look at 37. This is one where you had to solve for x. Let me draw the picture. Okay, so in question 37, you have a picture, but you also have a similar statement, and that is really important. So the important part of this is you're told that triangle WLJ is similar to triangle QBV. Okay? So why is a similar statement important? Julian? Okay. Yes, it tells us that they are the same shape, just different sizes. But how can I use the similar statement to solve for x? Because that's what we need to do.
It shows what side is similar to what side.
What side corresponds to what side. Very good. And that's what we need to do here, okay? So what does WJ correspond to in the other triangle? QV. So I'm going to say that x plus 6 over 8 is equal to, are we good so far? And then I would say x, what does LW correspond to? QB, well, QB is the same as 5. Sorry, x over 5. When I cross multiply here, do I have a quadratic like I did on the quiz? So it's not an extra credit situation. So let's go ahead and try to solve it, okay? So I'm going to, when I cross multiply, I have 5 times x plus 6. We will have to distribute that, okay? So I have 5x plus 30 equals 8x. Subtract x, 5x, I'm sorry, to give you 3x. So x is 10. Now, what did the question ask us in 37? It said find the value of x and the scale factor, okay? Now remember, the scale factor, it says of the polygons. I'm going to go from the one on the left to the one on the right, okay? So the one on the left would just be 8 to 5. Would you agree with that? The scale factor is just 8. No, wrong way. Sorry. Hang on. Not 8 to 5. That's 8 to 5 is over here. Scale factor would be x is 10. So 10 to 5, or 2 to 1. Better? Lucia, better? Okay, good. All right then, go ahead and put your homework away. We're going to do a little activity here. You do need to make sure that you put everybody's name on your sheet here. This says patterns with scale factors. You says names in your group. Just make sure everybody's name is on here. And we're going to do this little activity with blocks. So everybody at their table has some blocks. And I want you to start with only 4. So if you would kindly just get 4 blocks. And I want you to build the figure that you see here. So, and you can put it flat on your desk, that's fine. But just take these 4 blocks, maybe put it flat on your desk. Just to make it easier. You'll see why in a minute. So flat on your desk like this, 4 blocks. We're going to start with just these 4. Okay, everyone listening? Now, I'm telling you that we're going to call these blocks unit blocks, which means that each side has a length of 1 unit. Okay? So we're going to treat them as 1 unit. So what would be, of this 1 block, what would the perimeter of the base of the 1 block be? 1 plus 1 plus 1 plus 1. So what would it be? 4. The perimeter of the base of the block would be 4. What would the surface area be? No. 6. How'd I get that? Well, each surface, look at me, guys. I want to see Jason's eyeballs up here. What is area? Area of a square is just base times height. Would you agree? So if it's 1 times 1, what's the area of this? 1 times 1 is 1. So this area is 1. Now the unit squared, 1 squared, 1 unit squared. But how many of these surfaces are there on a cube? So isn't the surface area 6? You with me so far? All right. How about the volume of the cube? What do I do to find the volume? Good. So it's 1 times 1 times 1, which is just 1. So it's 1 unit cubed would be the units you would use. So I want you to take that idea and expand on it. Take your unit of 4 blocks, your 4 blocks, only dealing with these 4 right now, and I want you to fill in. We're going to call this our original figure, okay? This block of 4 is going to be your original figure. I want you and your group members to find the perimeter, surface area, and volume of that. And then I want you to double your figure, which means double all of the dimensions, double the height, the width, and the length, and find the new perimeter, surface area, and volume. Okay? I'll give you a couple minutes to work on that. All right. So you guys found in your original 4-block figure, what was the perimeter? 8. What was the surface area? Okay, and the volume? 4. Now, my sweet, lovable little daughter, who's 10 in 5th grade, was like, she's doing surface area and volume relationships in her 5th grade class. And she's like, Mom, I don't understand. Why is a volume smaller than the area? Can that happen? Well, it has to do with the units, right? What is volume measuring? The space on the inside. Give me some other words that can be used. Space on the inside. Depth, honestly, is a singular, it's just like a width and a depth. So that's like a linear measurement. But I understand where you're going with that. How much something holds. Capacity is a word that the SOL tends to use a lot, so I'm going to actually write that on here. If you want, one lucky person in your group can actually keep this. The rest of you should write it down in your notes, okay? I have a 3-hole punch, help yourself, but I do want you to go ahead and write another word for volume is capacity, and it is how much something holds, okay? Reese, are you throwing things? All right. When we took our blocks and we doubled all of the dimensions, the height, the width, and the length of our figure, what was the new perimeter of our base? The new perimeter was 16. The new surface area was 64. And the volume was, okay. All right. And we literally just counted the blocks to be able to answer that, correct? We can do much more than that, most of us. Now, to get our scale factor, we have to get from the original figure to the double figure, it'd be 8 is to 16, and we'll just reduce that, and that would just be 1 to 2. Okay, I agree. And then the surface area, the scale factor would be 16 to 64, but that reduces to 1 to 4. Good. And then 4 to 32 would reduce to be 1 to 8. Excellent. So almost all of us got to that point. And I came around to a few groups that got finished a little earlier than others, and I asked a simple question. I said, what do the perimeter, surface area, and volume have to do with the scale factors that are listed there? Did any of the 3 groups I talked to come up with an answer to that question?
Yeah,
Go ahead. Tell me what you guys group decided. What did you guys say? Any of you can speak. It doesn't matter. The question was, what do the perimeter, surface area, and volume have to do with the scale factors that you see here? All right. Maybe I'll give you a little hint. What if I rewrote the scale factors to look like this? 2 squared is 4. 2 cubed is 8. That's not a coincidence. The units for perimeter are just your units, your centimeter, your feet. Keep your hands to yourself, India. The next unit, surface area, is units squared. And then volume has units cubed. That's not a coincidence that the units go from units squared cubed, and so do the scale factors. Remember last class I told you that the perimeters and the sides have the same scale factor, right? We actually did a problem in class like that. And I said, oh yeah, the sides and the perimeter have the same ratio. But the sides and the surface area do not. But there's a relationship between them. If we know the side ratio, we can find the surface area ratio. If we know the side or the perimeter ratio, we can find the volume ratio. So I'd like to investigate that a little bit more. Okay? So let's say this is the problem I gave you. I said, here is the ratio of the sides of some, and by the way, the figures have to be similar in order for this to work, okay? I have to have a small cone and a large cone, or I have to have a small rectangular prism and a large rectangular prism. They have to be similar solids in order for this ratio thing to work. But let's say I had the ratio of the sides is 2 to 3. How could I find the ratio of the areas? What would I do? Right, so it would be 2 squared to 3 squared, which would be what? 4 to 9. Good. Nothing tricky here. What would the ratio of the volumes be? Okay, so which ratio am I cubing? The side ratio. So here's the key. I always have to know this one, don't I? Okay, so if I actually cube the 2 and I cube the 3, what is 2 cubed? 8, and 3 cubed? 27. Okay, so I can find the new ratios. All right, good enough. But I'm not always given the ratio of the sides. Okay, what if this time I'm going to give you the ratio of the surface areas, and I want you to find the ratio of the volume. Little different of a question. Okay? So again, I'm giving you the areas, ratios. I want you to find the volume ratio. Think back to what we just did in the previous problem. We had to have the ratio of the what? The original, which was the side ratio, or the perimeter ratio. I don't have that here. Can I find it? How? You see it? Square root. I'm going to go backwards. If you look at the previous problem, what did I do to get from the sides to the area? I squared it. To go backwards, I would square root it. Okay? So that's what I'm going to do. What's the square root of, what's the square root of 25? Okay? So the ratio of the sides, perimeter can also have the same ratio. It'd be 5 to what? Good, 5 to 7. Excellent. But that's not the question. The question says, what's the ratio of the volume? What would I do to get that? Cube this one, right? So it would be 5 to the third as 7 to the third, which is, y'all don't have your calculators here. I know it's 125. Y'all know 7 to the third? You what? You just did it? Look at you. Like I did the math. Come on, Ms. Maggart. So 125 to 3, 43. Good. That would be the answer. What if I give you the ratio of the volume and I want you to find the ratio of the areas? Could you do that? No matter what, I need which one? The first one, the original, which is the ratio of the sides, right? So I don't have that here. So how do I find the ratio of the sides here? What did I do to get from the area to the sides? I took a square root. What am I doing from the volume to the sides? Cube root. Okay. What's the cube root of 64? No. The cube root. 4 times 4 times 4 is 64. Now, you guys are allowed to use calculators with this. I should have probably had you check them out. That's okay. But I'm going to show you where on the calculator it is. If you hit the math key and you scroll down to option 4, there's your cube root function. Okay? And you can just say the cube root of 64, and you do get 4. Okay? So we have 4 to 5. Okay? We just did 5 to the third is 125. Or the cube root would be 5. So there's our ratio. What's the area? What's the area ratio? 16 to 25. Excellent. So the key with these types of problems is if I don't have the side ratio, I have to find it. So if I'm not given it, I have to work backwards, which means either taking the square root or the cube root to actually find the ratio of the sides. Once I have that one, then I can go ahead and find the others. So sometimes you're going backwards, sometimes you're going forwards. As a hint for me, what I tend to do is always write it in this order. Remember that perimeter also has the same as the side. So you could be given the perimeter, okay? But I always go sides, area, volume, so I know that that's the order that goes original, squared, cubed, so I don't get that confused. That's just my it's just me being OCD, but I can't help it. Okay? So I'd like to look at questions. Yes?
That way you can go from area to the next one, to the cube one.
The volume?
Yeah.
Oh, we did that.
No, I mean there's a way with like one, like.
In one step? I don't think so.
Yeah, I think there's a relationship between.
Okay.
Maybe, I don't know.
I don't think so. But maybe. Not that I'm aware of. Oh, we can work back to the sides. There's probably is. All right, so let's go ahead and look at a couple of real-life situations that I can see on the SOL that might come up. And the first one, you don't have to write this whole problem down, so just kind of watch it for now, okay? But if you would, let's look at this one and let's see what it's saying. It's asking us to see, are these cylinders similar? Are they similar solids? Well, what dimensions are given? How many of them are there? 2. Okay, so I can actually check by looking if 2 of the dimensions are the same, have the same ratio. Okay? So, what is the ratio of the height of the large cylinder to the height of the small cylinder? So the height would be 12. So it'd be 12 over 10. Don't those correspond? Right? The height, right? They correspond. Does that reduce? 2? 6 over 5. Okay? Good. How about the radius? Remember the radius is from the middle or the center of the base or the center of the circle out to the edge. That's the radius of the circle. And then this, on the larger one it's 6, on the smaller one it's 5. What do you notice? They're the same ratio, which means what's true about the 2 figures? They're similar. Okay? So now I'm going to ask a different question. What is the ratio of the volume? Oops. What is the ratio of their volumes? How would I answer that question? First, we've identified that, yes, they're similar. Second, how do I find the ratio of the volumes? Anybody? Come on. Do I have the ratio of the sides or the ratio of the areas like we did before? I do. I have the height dimension. I could use the height or the radius. I don't care, right? But I have these are the scale factors, aren't they? So I have that first ratio. So how do I find the ratio of the volumes? Just cube it, don't I? So isn't it just going to be 6 cubed over 5 cubed? Would you agree with that? And so 6 cubed is 216, and 5 cubed is done. And you would just leave it like that. Okay? All right, good enough. So we've already done this. We know that similar figures have an original scale factor. Their areas, by the way, this would be for perimeter as well. Perimeter, height, length, any of those one-dimensional measurements. Areas, you square them. Volumes, you would cube them. And we kind of discovered that with our blocks. So, I don't want to do this one, sorry. I want to do this one. So let's read this question. Shall we? Ain't it exciting? Everyone read it? Now, something that's not always obvious is weight. What is weight? Is it a length, a height? Is it a unit? What kind of a unit would it be? Is it a capacity measurement, how much something weighs? Kind of is, okay? So you're going to be thinking about this in terms of a volume, okay? The volume of the relationship. So just think about it from that perspective, if that helps. All right. What information am I given in this problem? Am I given a ratio of the sides? Am I given an original weight? What am I given here? I need a ratio of something. What ratio am I given? Say it louder. Yep. 3 times as big. So I have a marble paperweight. I guess marble meaning like it's made of marble, right? Like granite, marble. Okay. So I have a small pyramid paperweight, and then I have a similar one that's bigger. And I'm trying to figure out how much the bigger one's going to weigh. Weight is not the same ratio as the sides. Weight would be like a volume. So it doesn't have exactly the same proportion. But Jonathan's right. We are given the ratio of the dimensions. What is dimension, by the way? Is that a side, an area, a volume? It's a side, right? Dimension is like all the heights change, the width is changed, the radius is changed, whatever. Those are lengths. So dimensions is like a side, okay? 3 times as large, meaning that it goes from 1 to 3. Are we okay with that? 1 to 3. All right. So 1, keep writing the wrong thing. 1 to 3. And that would be from the small to the big paperweight. Would you agree? Okay. And that's the sides. What other information am I given in the problem? How much the small one weighs. The capacity, in a way, of the smaller one. Okay. Am I going to use the 1/3 to solve my problem? No. Well, I'm going to use it, but that's not the ratio that is in my problem. What is the ratio I want? Okay. I don't want to use all this garbage. Let me just do it this way. All right. So I have a ratio of, how many times am I going to do that today? Ratio of the sides, dimensions, whatever, is 1 to 3. Don't I need the volume, capacity? Let's use capacity because it's really weight. What ratio would it have? 1 to 27. I'm cubing them, aren't I? Isn't it 1 cubed to 3 cubed? Didn't we just do that? You're getting all confused because it's a word problem. You're like, hold the phone. But yeah, we're just doing it just fine. Okay, 1 to 27. So I'm going to use this ratio to come up with my answer. How much did the small one weigh? 0.15. Where should that go over here, the top or the bottom? Because it's the smaller one, right? And then we're trying to find the bigger one. So we're going to use this idea of finding the correct scale factor that I need to be able to answer the question. Okay? So we had to pull out the information from the problem that we knew. We knew that tripling the size meant that we tripled the dimensions, meaning the scale factor went from 1 to 3. Then we're looking at the capacity. We had to cube that to come up with the capacity ratio. And then we used the current weight in there. And let's cross multiply. Let's see what we get. Since I had the calculator, do you mind if I just do it up here? Is that okay? So 27 times 0.15 is 4.05. Does that seem reasonable for the weight of the enlarged marble whatever? Yeah. I think the units were what, pounds? Yeah, okay. So that's how you get. Now, what if I use 1 to 3? Would I get the same answer? I wouldn't. Okay? 1 to 3 gives us something else. So that would be 3 times 1.5. And that would say that it would be, 0.15, sorry. I was like, wait a minute. 3 times 0.15 is 0.45. Okay? Which is not the correct answer. I got to remember which ratio we're using. Okay? No big thing. All right, since you guys do have a 3-day weekend, lucky you, not so lucky me, I'm going to go ahead and just put your homework up on the board. I'm going to bring the problems over. If you can get it done in the next 30 minutes, homework-free weekend. Wouldn't that be awesome?
Oh, yeah.
Come on now. All right, let's go. There is your homework. I will try to text it to you. I know that School Fusion has been having some internet problems all day long. They said they fixed it, but they lied. Like, I can't get to my email. I can't get to anything. So I'm hoping I'll be able to put this recording up today, but I'm not holding my breath. It might not be till next week. I know I'm recording it. It's okay. That's your homework, and enjoy your 3-day weekend. Hope it doesn't snow too much.